A chemist wishes to create 100 milliliters of a solution with 12% acid content. He uses two types of stock solutions, one with 30% acid content and another with 10% acid content. How much of each does he need? Let's begin by identifying variables. Here, we'll let X represent the amount of 30% acid solution, and we'll let Y represent the amount of 10% acid solution. Now the goal using two variables is to set this up with a linear system with two equations. Now the first equation can be gotten from the fact that the chemist wishes to create 100 milliliters total. So the amount of the 30% acid solution plus the amount of the 10% acid solution should add up to 100 milliliters. That's our first equation. Now our second equation comes from the acid content in the correct percentage. So 30% of the amount X is the actual content, is the actual acid content in the first solution, plus 10% of the amount Y, so 0.10 Y, is the amount of acid in that second solution. Now the end result is to have a 12% acid content, or in other words, 0.12 of the 100 milliliters should actually be acid. So this is our setup. The total amount and the total acid content. So we can choose to solve this linear system any way we want. In this case, I'll use the elimination method. To eliminate the variable y, we can multiply both sides of the first equation by negative 0.10. That'll give us an equivalent system. Negative 0.10x minus 0.10y equals negative 0.10 times 100 is negative 10. And for the second equation, 0.12 times 100 is 12. And we can see here the variable y is lined up to eliminate. Now let's add these equations together, and we're left with 0.20x equals 2. Dividing by 0.2, we have x equals 10, or 10 milliliters of the 30% acid solution. Now all that's left to do is back substitute to find the amount of the 10% acid solution. Using x plus y equals 100, we'll substitute x is equal to 10. So 10 plus y equals 100. Subtracting 10, y equals 90. Or 90 milliliters of the 10% acid solution.